Chapter 12: Association between variables measured at the ordinal level. There are two common types of ordinal level variables. Some have many possible scores, and look, at least at first glance, like interval ratio level variables. We call these continuous ordinal variables. An attitude scale that incorporated many different items and, therefore, had many possible values would only produce this type of variable. The second type, which we call a collapsed ordinal variable, has only a few values or scores and can be treated either by collecting data in collapsed form or by collapsing a continuous ordinal scale. For example, we would produce the collapsed ordinal variables by measuring social class as upper, middle, or lower by reducing the scores on an attitude scale into just a few categories. A number of measures of association have been developed for use with collapsed ordinal level variables. The most commonly used statistics in this group include gamma, Summers D, Kendall's tau B, and Kendall's tau C. For continuous ordinal variables, a statistic called Spearman's rho is typically used. Gamma, Kendall's tau B and tau C, and Summers D are conceptually similar to one another. They measure strength and direction of association by comparing each respondent to every other respondent, called a pair of respondents or simply a pair, in terms of their rankings on the independent and dependent variable. The total number of unique pairs of respondents in a dataset can be found by the following formula. N equals n minus 1 divided by 2, where n equals the total number of respondents. Pairs can be further divided into 5 subgroups. A pair of respondents is similar if the respondent with the larger value on the independent variable also has the larger value on the dependent variable. A pair is dissimilar if the respondent with the larger value on the independent variable has the smaller value on the dependent variable. A pair is tied if respondents have the same value on either the independent or dependent variable or on both. Specifically now, a pair is tied on the independent variable if both respondents have the same score on the independent but not the dependent variable, while a pair tied on the dependent variable if both respondents have the same score on the dependent variable but not the independent variable. Finally, a pair is tied on both variables if both respondents have the same independent and dependent variable scores. Gamma, Kendall's tau B and tau C, and Summers D measure the strength of association between variables by considering the number of similar versus dissimilar pairs. When there are an equal number of similar and dissimilar pairs, the value of these statistics will be equal to 0, indicating no association between the independent and dependent variables. As the number of the similar relative to dissimilar, or dissimilar relative to similar increases, the value moves closer to 1. Therefore, the larger the difference between the number of similar and dissimilar pairs, the stronger the association. When all pairs are either similar or dissimilar, the value of these statistics will be equal to 1, indicating a perfect relationship. It is also easy to determine the direction. If the sign of the statistic is a plus, direction is positive, a minus sign indicating a negative relationship. A positive relationship means that the scores of the respondents tend to be ranked in the same order on both variables. In more general terms, a positive relationship means that the variables change in the same direction. Negative relationships are the opposite of positive relationships, in the sense that low scores on one variable are associated with high scores on the other, and vice versa. Below are tables that represent the strength and direction of relationships, with the top table indicating the relationship between the value of ordinal level measures of association and the strength of relationship, the bottom left a generalized positive relationship, and the bottom right a generalized negative relationship. Gamma is the number of similar over dissimilar pairs as a proportion of all pairs excluding ties. The formula for gamma is as follows. G equals ns minus nd divided by ns plus nd, where ns equals the number of pairs of respondents ranked by the same on both variables, and nd equaling the number of pairs of respondents ranked differently on the two variables. Gamma ranges from -1 for a negative relationship to +1 for a positive relationship, and a value of 0 indicating no relationship. Gamma is a symmetrical measure of association, so its value will be the same regardless of which variable is taken as a dependent. Gamma is also the only measure to include proportional reduction in error interpretation, also known as PRE, which measures this value gained by predicting one variable while taking the other into account based on predicting the order of pairs of respondents. The major limitation of gamma is that it ignores tied pairs of cases and as a result can exaggerate the strength of association between two ordinal variables. Kendall's tau B includes both pairs tied on the independent variable and pairs tied on the dependent variable. The formula for computing Kendall's tau B is as follows: Tb equals ns minus nd divided by the square root of bracket ns plus nd plus tx multiplied by bracket ns plus nd plus ty, where ns equals the number of similar pairs, nd equals the number of dissimilar pairs, tx equals the number of pairs tied on the independent variable x, and ty equaling the number of variables tied to the dependent variable y. Kendall's tau B ranges from -1 to +1 and does not have a PRE interpretation. When the independent and dependent variables do not have the same number of categories, the variant known as Kendall's tau C should be used instead of tau B. Kendall's tau C adjusts for the number of categories and is designed to reach a max of 1 for variables with different numbers of categories. Therefore, Kendall's tau B should be used for equal amount of categories and tau C for when they are not the same. The formula is as follows: Tc equals 2m bracket ns minus nd close bracket divided by n squared bracket m minus 1, where ns equals the number of similar pairs, nd equals the number of dissimilar pairs, n equals the number of respondents, and m equals the minimum value, whichever is less of the number of categories on the independent or dependent variable. Like tau B, tau C ranges from -1 to +1 and does not have a PRE interpretation. The formula for computing Summers D is indicated below. dyx equals ns minus nd divided by ns plus nd plus ty, where ns equals the number of similar pairs, nd equals the number of dissimilar pairs, and ty equals the number of pairs tied on the dependent variable y. Summers D ranges from -1 to +1 and is asymmetric in measure. Therefore, two values of Summers D can be computed: dyx, where y is treated as a dependent variable, and dxy, where x is treated as a dependent. Like Kendall's formulas, Summers D does not have a PRE interpretation. As previously mentioned, gamma has its limitations in where the result of a PRE interpretation can exaggerate the strength or association between the two variables. Also, Kendall's tau B is limited in the sense where it can reach a max of 1 only when the independent and dependent variables share the same number of categories. There is no hard and fast rule on which ordinal measure of association to use. When there are relatively few ties, gamma should be used because it has a PRE interpretation and others do not. When there are many ties, gamma tends to exaggerate the strength of relationship, so use other measures instead. Kendall's tau B should be used when the independent and dependent variables have the same number of categories. Kendall's tau C should be used when the variables have an unequal number of categories. And finally, Summers D should be used when one of the variables is specifically identified as a dependent. Spearman's rho is a measure of association for ordinal level variables that have a broad range of many different scores and few ties between cases on either variable. To compute Spearman's rho, cases are first ranked from high to low on each variable, and then the ranks are manipulated to produce the final measure. The formula for Spearman's rho is Rs equals 6 multiplied by sigma of d squared divided by n bracket n squared minus 1, where sigma d squared is the sum of difference in ranks, the quantity squared.
Using what we've just learned, we'll show you how to interpret the direction of relationships using the variables of income and health. Let's go into the 2009 GSS shortened dataset and examine the relationship between gamma, Kendall's tau C, and Summers D. To do that, we will first hit Analyze, Descriptive Statistics, and use a crosstabs program with total household income as the independent variable and health as the dependent variable. In the crosstabs dialog box, click the Statistics button and request Gamma C, Summers D, and Kendall's tau C. We have selected Kendall's tau C given the unequal number of categories on the independent and dependent variables. We'll also need to click on the Cells button and make sure that column percentages are requested. Next, hit Continue, click OK, and now we'll examine the output. So first, let's take a look at gamma in the Symmetric Measures output box. A value of negative 0.137 indicates a somewhat negative relationship. So, the higher the outcome, the lower the health, right? Wrong, actually. Look at the codes for health. A low score indicates a high level of health. The negative sign for gamma is telling us that the higher scores on total household income are associated with a low score, a score of 1 or good, on health. Despite the negative sign, this is a really positive relationship in the sense that health improves with income. Always inspect tables carefully to make sure that you are inspecting the direction of relationship properly. Looking next at Kendall's tau C, a value of negative 0.105 indicates a weak to moderate relationship. This value is much lower than gamma, as is Summers D reported in the Directional Measures output box. Also, notice that there are 3 values of Summers D. The symmetric version of Summers D is a type of average of the 2 asymmetrical versions of Summers D. DYX, which is the health dependent, and DXY, which is the income dependent. So, which of these statistics should we use? Gamma tends to exaggerate the strength of a relationship, so either Kendall's tau C or Summers D will likely offer a more realistic picture of the strength of association between income and health. Further, if one of the variables is specifically identified as the dependent variable, for example, health, then asymmetrical Summers D, so the negative 0.098 figure, is likely the most appropriate measure of association. Let's take another look at a relationship between 2 ordinal level variables. The question this time is, does disability vary by age? So again, we'll go to Analyze, Descriptive Statistics, and crosstabs, and as you can see, we have 2 new variables. The first being HAL Q410, which asks, are your daily activities at home, work, or school limited by a physical condition as the dependent variable, and AGE-GR5, which is age, as the independent variable. We click OK. We can see that the latter category, which is age, has way too many categories to be used in a bivariate table. As such, we must first recode the variable. So we have decided to collapse the values of AGE-GR5 into 3 categories. To do this, we went to the Transform column, hit Recode into different variables, got our variable we wanted to change, which was AGE-GR5, and gave it a new name, which is age3. Next, we went to old and new values, and assigned values through, we assigned new values to everything else. So the first range is 1 through 6, which would have the new value of 1, 7 through 10, which the new value would be 2, hit add, and 11 through 15, now we have all 15 categories accounted for, which new value would be 3. Next we hit continue, OK, and now we have new data. Let's now examine the relationship between HAL Q410 and AGE3 with gamma, Kendall's tau B, and Summers D. Using crosstabs once again with AGE3 as our independent variable, the dependent variable HAL Q410 will go in rows. Again, we have to request gamma, Kendall's tau B, and Summers D. Again, go to Cells, and request column percentages, hit continue, and the output, slightly edited for readability, should look like this. A gamma of 0.529 indicates a strong positive relationship. Older respondents, which would be a score of 3 on AGE3, had the highest percentage who reported often or always, which means has daily activities limited by a physical condition, and younger respondents had the highest percentage who reported no to daily activities limited by a physical condition. As age increases, having a disability increases. Not surprisingly, Kendall's tau B, with a value of 0.203, is much lower than gamma and indicates a moderate relationship. Similarly, if we take HAL Q410 as the dependent variable, then Summers D 0.111 also offers a more modest picture of the strength of relationship between age and disability.